Assalamualaikum class. In this video we are going to discuss the remaining part of exercise 1.6 quadratic equations and its applications. We have in the previous video we have discussed the three methods that are basically by factorization, square root property and completing square method, and we have derived the quadratic formula using completing square method on the general form of or the standard form of quadratic equation, and now we will apply the quadratic formula to solve the quadratic equation. So here we have question number 20 from the exercise: y square minus 4y plus 7 is equal to 0. And comparing the coefficients, or comparing the equation with the standard form of quadratic equation, which is ay square plus by plus c is equal to 0. A will be equal to 1, b will be equal to minus 4, and c will be equal to 7. Now by quadratic formula, y will be equal to minus b plus minus square root b square minus 4ac over 2a. Inserting the values of a, b and c in the expression, we will simplify it further for the value of y, and here we get the value of y. Iota is appeared because of this negative sign. As we know that whenever we are having negative sign in the square root, this is going to be a complex number represented with the help of iota, and the square root of 12 is going to be 2 square root of 3, and here is the final answer for this. Next we have question number 22. Y square minus 4y plus 1 is equal to 0. Comparing it with the standard form of quadratic equation, ay square plus by plus c is equal to 0. A will be 1, b will be minus 4, and c is 1. So here you can notice that we have to take the negative sign in the term. We cannot neglect it. So b is equal to minus 4. Now inserting the values in the quadratic formula, y will be equal to 2 plus minus the square root of 3. Next we have question number 24. 9s square plus 2 is equal to 12s. So at first we will shift 12s on the left hand side so that we have 0 on the right hand side. Now comparing it with the general equation, ax square plus bs plus c is equal to 0. A will be 9, b is minus 12, and c is 2. Now inserting the values in quadratic formula, we get the solution as shown in the further. So here you can see that I can take 6 common from this. So 6, 2 plus minus square root of 2 over 18, and this 6 and 6 18 can be cancelled out with 3. So here is the final answer for this. Then we have question number 26. 9s square plus 7 is equal to 12s. Again, at first we will make 0 on the right hand side, as 9s square minus 12s plus 7 is equal to 0. Comparing it with the standard form of equation, quadratic equation, a is 9, b is minus 12, and c is 7. Inserting the values in quadratic formula, we get a complex number as an answer. So you can see that these are basically calculator based questions. So you just need a calculator, and you have to remember the quadratic formula when you are going to solve any quadratic equation with the help of quadratic formula. Next we have nature of the roots of quadratic equation. So we can discuss the nature of the roots of quadratic equation without completely solving the equation, but at first we will solve it to decide or to develop a method for this, to discuss the nature of the roots. So at first, let's suppose we have the equation 2x square minus 3x minus 4 is equal to 0. Clearly a is 2, here b is minus 3, and c is minus 4. Inserting the values in quadratic formula, here we get x is equal to 3 plus minus the square root of 41 over 4. So we are having two different real numbers as an answer, so we are having distinct and real roots. Now we have the equation 4x square minus 4x plus 1. Clearly a is 4, b is minus 4, and c is 1. By using quadratic formula, we get square root of 16 minus 16, that is 0. So 4 plus minus 0 over 8. So either we add 0 and 4 or subtract 0 from 4, it remains the same. So the answer is 1 by 2 and 1 by 2, that is we are having real and repeated roots. And the third one, 2x square minus 3x plus 4, with a is equal to 2b minus 3 and c 4. The quadratic formula gives us x is equal to 3 plus minus the square root of minus 23 over 4, and clearly these are going to be the complex root because of this negative sign in the square root. So now we will discuss that how we compare the nature of the roots. That you can see that whenever we have distinct and real roots, it is only possible when discriminant is positive. So whenever we take square root of some positive number, we get some real number, and by adding and subtracting the real number, we get two different answers. So whenever d, or this part which is basically b square minus 4ac, named as discriminant, because this is the basic part which is making the difference in the nature. If the square root 1, if the expression in the square root is positive, we are going to have distinct and real roots, that is discriminant must be positive. If the expression in the square root is 0, so 4 plus 0 and minus 0 are going to be the same, so So we are having real and repeated roots for discriminant 0, and for discriminant negative we are having complex roots. So b square minus 4ac, or the discriminant, is the basic one or the basic identity to discuss the nature of the roots. Whenever it is positive, we are going to have real and distinct roots. For 0 we are having real and repeated roots, and for negative ones we will have complex roots. For example, if you are asked to find out the or to discuss the nature of the roots without solving the equation, and the equation is x square plus 2x minus 1, and you have to describe the nature of the roots, we will compare it with the general form of quadratic equation to get the values of a, b and c, which are 1, 2 and minus 1 in this case, and then we will find out the discriminant, which is positive. It means we are going to have real and distinct roots in this case. Next, we have some word problems related to quadratic equation. So we have question number 80. Find all numbers with the property that when the number is added to itself, the sum is the same when it is multiplied by itself. So let's suppose the number is x, and when the number is added to itself, that x plus x, it is the same, that is equal to when it is multiplied by itself. So we are having x into x. So x plus x is 2x, x into x is x square. So x square minus 2x is equal to 0. Now, in order to solve this equation, you may factorize it, or you may apply completing square method, or you may use quadratic formula, but I will go for the factorization. So I will take x common. X into x minus 2 is equal to 0. It implies that x is equal to 0 or x is equal to 2. Then we have question number 82. The sum of a number and its reciprocal is 10 by 3. Find the number. So let's suppose the number is x. So clearly its reciprocal is going to be 1 by x, and their sum is x plus 1 by x, which is equal to 10 by 3. So we will take LCM at first. X square plus 1 over x is equal to 10 by 3. Then we will cross multiply the two expressions, so that we get 3x square plus 3 is equal to 10x, and then we can shift 10x on the left hand side in order to make the general form of quadratic equation. 3x square minus 10x plus 3 is equal to 0, with a 3, b minus 10 and c 3. Now we will apply the quadratic formula so that we get the answer 3 and 1 by 3. Next, we have question number 84. Find base b and height h of the triangle with area of 2 square feet if its base is 3 feet longer than its height, and the formula for area is half base into height. So as the relation is given that the base is 3 feet longer than its height, so let's suppose the height is x, then base will be 3 feet longer. Longer means we are going to add the number, so x plus 3 will be the base. Now by the formula, a is equal to, or the area is equal to half base into height, so base is x plus 3, height is x 1 by 2 as it is, and area is already given in the question, which is 2 square root feet, so 2. So this 2 will be multiplied over here. 4 is equal to x square plus 3x. This x's will be multiplied with the both terms, so x square plus 3x minus 4 is the quadratic equation that we will solve. You can use quadratic formula or factorization or completing square on this one, and I am going to perform the factorization. You may apply the quadratic formula as well, and x is equal to 1 and minus 4, but this is not the final answer. We have to find out the base and height of the triangle, and we know that the length can never be negative, so it means we will take x is equal to 1 only, not minus 4. So when x is equal to 1 means height will be equal to 1 foot, and base is equal to x plus 3, that is 4 feet. Thank you.